Hello guys, and welcome to today's video where we'll be looking at sequences and series objective test questions, and these are WAEC past questions that we'll be looking at in elective or further mathematics. Right, so let's have a look at the first example. We have an exponential sequence is given by 3 on 4, that's the first term, 9 on 2, the second term, 27 the third term, and it continues. We have to find the common ratio. We have the options given to us. A is 1 on 6, B is 2 on 3, C is 3 on 2, and D is 6. This is the SSCE 1993 question number 7. Alright, so let's write down the solution to this problem. So solution. Now to find the ratio in an exponential sequence or GP, the common ratio is equal to U2 on U1, where U2 is the second term. Okay, this is the second term. U1 is the first term. Okay, or what it basically means is that, for instance, if I look at what I have here, let me use a different color to show that. If I look at what I have here, this is my first term, this is my second term. I can either use the first term and second term, or the third term and the second term, right? That is how it goes. You don't jump any term. So if you're using the third term, use U3, U2. If you want to use the first two, you use U2, U1. That is how we find the terms for using in our common ratio. All right, so in this case, our U2 in this case is 9 on 2, so I have 9 on 2 here. My U1 is 3 on 4. Okay, so from here, finding my common ratio is very simple. I have my U2, which is 9 on 2, divided by, okay, that's the division sign. The U1 is 3 on 4. Okay, so from here, all we have to do is to simplify this. We can divide this as it is, so we reciprocate 3 on 4, and then we change the division sign to multiplication. So I have that becoming multiplication sign, and then 4 over 3 here. So R is now equal to 3 will divide itself 1, will divide 9 3 times, 2 will divide itself once, divide 4 twice. So I have 3 multiplied by 2 at the top, which is 6, then 1 multiplied by 1 at the bottom, which is 1. So therefore my common ratio is 6. So the correct answer over here for example number 1 is option D over here. So that is our correct answer. All right, let's have a look at the second example for this question. Now the fourth term of a linear sequence is 19 and the 11th term is 54. We have to find the 8th term. We have the options: A is 5, B is 33, C is 39, and D is 44. This is the SSCE 1993 question number 26. All right, so let's have a look at the solution to this problem. Now to find the term, okay, let's say the nth term in a linear sequence, we use the formula UN is equal to A plus n minus 1 multiplied by D. Now the UN is the number of terms. Let's say whether it's the first term, the second term, third, fourth, until infinity. The UN is the number of terms. Now the A, the first letter over here, A, represents the first number in that particular sequence. For instance, if I have 1, 2, 3, 4 as my sequence, 1 over here becomes my first number, and that becomes the A. Now the difference between the second and then the first number, or the third and the second number, or the fourth and the third number becomes our difference. That's the difference between two continuous numbers. That is how we find the D over here. So in this case, we're told that U4, the fourth term, is equal to 19. So we have U4 is equal to 19, and then the 11th term, so U11 is equal to 54. And then the question is demanding that we find U8. So that is what we are going to do. Now all we have to do is to try to put this into this equation and try to find the first term, the difference, that is a and d, and then after we find the a and d, we use that to find the eighth term, because as it stands right now, we don't know the number that starts the sequence, and we don't know the number that is that ends the sequence, and we also don't know the difference. But we can find the eighth term if we know the first number and then the difference between the numbers. So let's do that. So for u4 will be equal to, that is the number of term, n over here is the number of term. So for u4, n is equal to 4. So that will become a plus n minus 1 d. Okay, so u4 from the question is 19. So I have 19 is equal to a, which we don't know, plus n is 4, since we are dealing with u4, so n is 4, so minus 1 multiplied by d. We do not know what the value of d is. So I have here 19 is equal to a plus 4 minus 1 is 3 multiplied by d, and this becomes my equation 1. Okay, so let's get some space here. Okay, so from here I can proceed to find u11. So my u11 will also be equal to a plus n minus 1d multiplied by d. Now u11 is given to me as 54, and that is equal to the first term, which I do not know, as a, and then since it's n u11, my n is equal to 11, so 11 minus 1 multiplied by d, which I do not know. So I have 54 is equal to a plus 10d. Okay, so now from here, let me just make a the subject. So I maintain the a here, and I send the 10d to the other side, so it becomes 54 minus 10d is equal to a. So therefore my a is equal to 54 minus 10d as my equation 2. All right, so to find the value of d, I substitute equation 2 into equation 1, and then I get the value for d, or the difference. So let me just quickly write the equation 1 here so that I erase this side. So 19 is equal to a plus 3d. That is my equation 1. All right, so let's get some space and we continue. Okay, so from here, what I will do is I'll substitute equation 2 into equation 1. So equation 2 into 1, that will give me 19 is equal to a is 54 minus 10d, then plus the 3d I have over here, so 3d. So I have 19 is equal to 54, then minus 10d plus 3d will give me minus 7d. Okay, so from here I have 19, I have 54, I group them at one side so that I can be able to divide easily to get the value of d. So I send d to the other side of the equal to sign. I have 7d is equal to 54, and I bring the 19 to the other side, it becomes minus 19. So 7d will be equal to 54 minus 19 will give me 35. So I divide both sides by 7, that is to get a value of d, which is my difference. So therefore my difference, if I do the division, is equal to 5 over here. Right, so now that I found the value of d, which is the difference, let's proceed to find the first term, and then from there we can proceed to find the eighth term as the question demands. So let me quickly erase what I have over here. Okay, mind you, to find the equation is a is equal to 54 minus 10d. Keep that in mind. Okay, so using equation 2, we have a is equal to 54 minus 10d. So A is equal to 54 minus 10 multiplied by D, which is 5. So I have A is equal to 54 minus 10 multiplied by 5 will give me 50. Then my A will now be equal to 55 minus 54, sorry, minus 50, and that will give me 4 as my answer. All right, so now I've been able to find the difference, which is 5, and then the first term, which is 4. So it means that the sequence starts at 4, and then the difference, or it increases by 5. So from 4 we have 9, and then from 9 we have 13, and so on and so forth. Right, now you can write that down quickly and use that to find the 8th term. That's by adding 5, 5, 5, 5, 5. Or you can simply use the formula, which in this case will become U8 is equal to A plus into bracket n minus 1 multiplied by D. Okay, so our 8th term will be equal to the first term, which is 4, plus we want to find the 8th term, so the n is 8 minus 1 multiplied by D, which is 5. So U8 will be equal to 4 plus 8 minus 1 is 7, and then 7 multiplied by 5 will give me 35. So I have 35 here. So my 8th term will be 4 plus 35, and that will give me 39 as my answer. So the correct option for this example is option C, and that is equal to 39. Now if you look at this question, even though it is an objective question, you realize that you need to do some substitution, form some equations, and solve to find the first term, the difference, and using those two you find another term. So even though it is an objective question, in this case it can also come as a subjective question for you. So it is good if you know or you have a clear understanding of these sequences and series before you go into the examination hall. And this is why we are taking our time to solve these problems one after the other to show you what to do. All right, so let's proceed with the next example that we have. So the question, example number 3, the first and second term of a linear sequence are 15 and 12 respectively. We have to find the nth term, and then we have the options. A is equal to 18 minus 3n, B is 12 plus 3n, C is 12n plus 3, and D is 12 minus 2n. This is the SSC 1993 question number 45. All right, so let's look at the solution to this problem. Now, we're told that the first and second term of this linear sequence are 15 and 12 respectively. So it means that this sequence starts from 15, then we have 12, then it continues, right? This is how the sequence is. We have to find the nth term. Now, the fact that we're given the first and second term makes it easier for us to solve this problem. Now, to find the nth term, un is equal to A plus into bracket n minus 1 multiplied by D. That is the formula we use to find the nth term of a particular sequence. Now, the A is the first term, which in this case is equal to 15. And then the D we have here is the difference, which is what? The second term minus the first term, right? So that will be U2 minus U1. And then the U2 in this case is our 12 minus the U1, which is 15. So the difference here is minus 3 over here, because we can see the number is decreasing rather than increasing. So it makes sense that our difference is negative. Now, the n, okay, in the formula over here, the n is the number of terms that we want to find. And in this question, it has not been specified. They just say the nth term. So our nth term is just going to be n, right? We just leave it like that. So to find the nth term, un will be equal to the first term, which is 15 in this case, plus into bracket n minus 1 multiplied by D, which is the difference, and that is negative 3. So I put that also in bracket. So from here I have un is equal to 15 plus negative 3 multiplied by n will give me negative 3. Negative 3 multiplied by negative 1 will give me positive, sorry, this will give me negative 3n. And then negative 3 multiplied by negative 1 will give me a positive 3. So my nth term is 15 minus 3n plus 3. And then from here, let me proceed over here. My un will be equal to, I have 15, I have 3. So 15 plus 3 will give me 18. So I have 18. Sorry, this is supposed to be minus. So I have 18 minus 3n as my final answer. So from the possible options given to me, I can see that A is the right answer for this particular question. All right, so let's proceed to look at the next set of question that we have. So example number 4, we have an exponential sequence, which is geometric progression. Is defined by 30, 15, 7.5, and it continues. We have to find the sum to infinity of this sequence. We have the options: A is 15, B is 30, C is 45, and D is 60. And this is the SSE 1994 question number 4. All right, so let's look at how we solve this problem. So we write down our solution. Now we're told that the exponential sequence starts from 30, goes to 15, then goes to 7.5, then it proceeds. Right, so we have to find the sum to infinity of this particular sequence. Now, to find the sum of a geometric progression, we use the formula Sn is equal to A, which is the first term, multiplied by 1 minus r raised to the power n, all on 1 minus r, where r is the ratio, that is u2 minus u1. As we've seen, n is the nth term. Okay, now, but note that in this case, we're asked to find the sum to infinity. Now, if they say we should find the sum to infinity, it becomes S infinity, and then that will be equal to, now, 1 minus a number raised to infinity, right? A number raised to infinity will be just, very small, that it becomes negligible, right? It becomes negligible. It will never, ever be 0, but to be closer to 0. So that will be negligible. So we can just say that the top we have over here will not really be useful anymore for us. It's more or less like we approximate it to 1, because r raised to the power n, which is r raised to the power infinity in this case, is almost like 0. So a multiplied by 1 will give us a. So we have a at the top over here on 1 minus r, and this becomes the formula we'll use to find our sum to infinity. Now we have our first term, which is our a, is from this thing given to us is 30, and then our r, which is the ratio, we don't know, so we find the r. So to find the r is u2 minus u1, and that will be equal to the u2. If I look through the sequence, the u2 is 15, that's the second term, so that is 15 on the u1, which is 30, and this is equal to half, because 15 will go into itself 1, go into 30 twice, so this becomes half. So from here I can use my formula S infinity is equal to a, which is 30, on 1 minus a half, which is the ratio. So this is equal to 30 on 1 minus half will give me half, because I have a whole, I took half of it, and I'll still have half left, so I have half. Now a number divided by half will be double the number, or we can do this as 30 divided by half, okay, which, okay, if we continue to solve like let's say someone who doesn't know, we will have 30 multiplied by, because this is division, we reciprocate and then we change the sign, so it becomes 2 on 1, so this becomes 60. 30 multiplied by 2 on 1, and this will give me 60 as my final answer. So if I look through the possible options, I have option D, which is 60, and so that becomes my correct answer. All right, then let's look at the next question for this particular sequence and series. So example number 5. The second and fourth terms of a linear sequence are 9 and 17 respectively. We have to find the common difference. The A is 2, B is 4, C is 5, and D is 8. And this is the SSCE 1994 question number 23. Now this question is actually very, very simple. So let's go ahead and look at that. So we write down our solution. We're told that the second term, so U2 is something and U4 is also something. So the second and fourth term of a linear sequences are 9. So U2 is 9 and then U4 is 17 respectively. We have to find the common difference. Now, because we don't have U3 or U1, we cannot find we cannot find the difference that easily, because these numbers are a number apart from each other. So to do that, we know that the nth term un is equal to a plus n minus 1 multiplied by the difference, right? So since we have u2, we can use the value 9 into this equation and find an equation, and then use the value 17 for u4, also find an equation, and then we can solve those equations to find a common difference. Now for u2, then n is 2, that is the number at the bottom. For u4, the n from in this formula is 4, so take note of that. So for u2, using u2, I will have a plus 2 minus 1 multiplied by d. My u2 is 9, so it's equal to a plus 2 minus 1 is 1, so multiplied by d over here will give me just d. Then from here I can make a the subject, so a will be equal to 9. I send the d to the other side, so it becomes 9 minus d as my first equation. All right, so from here I can use u4 to find another equation. So u4 will be equal to a plus the n is 4 minus 1 multiplied by d. The u4 is 17 is equal to a plus 3d. Okay, so this becomes my equation 2. So I substitute equation 1 into equation 2. I get 17 is equal to the a becomes the equation 1. So I have 9 minus d, then plus 3d over here. So I have 17 is equal to 9 minus d plus 3d. I just removed the bracket. So 17 here will be equal to, now minus d plus 2d, 3d, sorry, will give me 2d. So I have 9 plus 2d. Okay, so I maintain the 2d here and send the 9 to the other side of the equal to sign, so that 2d stands alone. So I have 17 minus 9. Okay, that's not right in there, so let's do it here. So I have 17 minus 9 will be equal to 2d, and so 17 minus 9 will give me 8, and this is equal to 2d. To get the value of d, which is the difference, I divide both sides by 2, the coefficient of the d, so this cancels this, so my d is equal to 8 on 2 will give me 4 as my answer. So therefore the option B is the correct answer for this particular example. All right, so let's proceed to look at other examples. Thank you so much for watching, and I think we'll stop here and then we'll continue in the next video, where we'll be using a common preamble to continue and solve more examples. So starting from example number 6 all the way to where we can stop before we do the part 3. So thank you so much for watching the first part, and I will see you in the second part. Bye bye.